application of differentiation is chapter 10. So we'll focus on how we can use the derivative. Okay, the first exercise is called tangent and normals. It's a really interesting thing. Okay, I'm recording myself. I shouldn't say something bad, but it's really interesting for this normal. The new study design 2016, they took this word out. Like, we not talk about normal anymore. Okay, there's no. Everyone know what's a normal? Yeah, the one perpendicular to the tangent, that's the normal on the curve. Well, we have a curve, we have the tangent at that point, and then perpendicular to that, that's the normal, right? So that's the normal. So everyone know what's a normal. But they said, no, we want to give less content to the student. So we took the normal out. Okay, we took it, but we still tested it. How will we test it? We will say there's a line perpendicular to the tangent and pass through the same point where those two graph contact. It's exactly the same as the normal. And it's so simple, we just say that's a normal. All of this description is to describe a normal. And we won't test normal anymore, but we test about the perpendicular line to the tangent and pass through the same point. Great. So we still learn normal. But in your SAC, in your homework, anything, we are not allowed to use the word normal anymore. Like, I can't use normal. Okay, if I use normal and you read the study design and you can call VCAT, my school is not doing it properly. Miss Liu is still using the word normal. I will be in trouble. So I will use the sentence like a line perpendicular to the tangent, pass through the same point. Blah, 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 blah. And you know that we are talking about the normal. Okay? So that's a little bit explanation. So this word shouldn't be here, but because it's a class notes, no one really cares. So I think it's better to leave as a normal here. Okay, so what we're going to talk about today is how to find tangent and normal, as exactly the same as what we learned in year 11. But there's something we want to start with. Okay, I draw a quadratic, not quadratic, like polynomial maybe. Cubic. Let's draw a cubic. Well, any cubic, not necessarily be the same as mine. And okay, at this point, well, a point close to here, like close to the turning point, I want you to draw a tangent, okay, approximate tangent to me. Okay, so draw a tangent. Not necessary to be really accurate, but like somehow looks like a tangent. So my one looks like this. Okay, that's the tangent at the point A, comma, FA. Okay, that's my tangent. Okay, my question is, anyone know what's the definition for a tangent? Do you know what's a tangent? Or if I ask you to describe a tangent, what you will say? Gradient? Okay, a gradient of given point is equals to f dash a, and the gradient of that linear is the same. Okay, that's one way to explain it. Any other ways? Well, think about the graphical thing. About intersections, give you a hint. Touch it only once. Okay, touch it only once. So if you touch it twice, is that a tangent? Okay, now let's do this. I will extend this red graph further this way, and I'll extend this linear a little bit longer. What you will see? Okay, a touch. Okay, is that a tangent?
No, it's the tangent at that point, but not the tangent.
Okay, then according to the definition you give me, you said only touches the graph once.
At one point.
Well, for example, I understand what you're trying to say. Okay, let's say f dash a equals the gradient of this line. Okay, ignore my sketching error or something like not that accurate. And I still make a touch here. Okay, I extend this longer this way, and I extend this linear longer this way. There's another intersection. Okay, it touched twice for fx, but this is still a tangent to that point. Okay, so how you can really test it, okay, how you can really test it. The tangent only touches once for an interval, okay. How do we see what intervals we should have? If we say this is the point B and FB, and this one can be, this turning point can be C and FC, and the point I have is A, FA. So this graph can be actually, I think, can be cut into 3 intervals. So minus infinity to B, and B to C, and then C to infinity. This actually separate the different paths, okay, separate different paths, because in that interval, okay, A belongs to which interval? A belongs to the C to infinity interval, okay? It's not going up and down, okay? Only increasing one-to-one function, only increasing, only decreasing, or only increasing, like in 3 different intervals. So for A is the value greater than C, so it's in the 3rd interval. So in that interval, I can only make the contact with the graph once. Okay, so in the interval C to infinity, I can't touch it twice. If like my sketching touch like this, okay, this one can't be the tangent, because in the same interval C to infinity, I have made contact twice with this graph. Okay, so intersections here and here. So then that's not going to be a tangent. So when you talk about touch only once, you only talk about one-to-one part, okay, one-to-one functions. So in the one-to-one session, I can only touch once, okay, I can only touch once. So this purple line is still a tangent, okay, still a tangent at x equals to A. Okay, it satisfies in that interval C to infinity only touch it once, okay. Does that make sense? Like the definition, if you only say touch once with the graph, is not that accurate, because this question shows you that it's not only touch it once, it touch it twice. But you may question yourself, why I find a tangent and I have 2 intersections, is that I'm doing something wrong? No, you haven't. It's just because for the one-to-one session, you have 1 intersection with the diagram and the tangent. Okay, that's the first thing. Okay, next thing is, for an exponential graph or logarithm graph, do you think the tangent only touch it once? For strictly increasing or strictly decreasing only, like log or exponential is only increasing functions, right? I draw a tangent at any point. Do you think that straight line only touch the fx once? Yes or no? Like it's a yes or no question. Have exponential, no, that's a log, and have exponential. And if I draw a tangent at anywhere of those 2 graphs, I can only intersect once. Is that true or false? True or false? True. Okay, because it's only one-to-one function and it's an increasing function, so only touch that interval once. So the whole interval is 1 interval because it's only increasing, okay, or only decreasing or only something. So for exponential logarithm, like those kind of one-to-one functions, if I draw a tangent, it will only touch it once. Okay, it will only touch it once. Okay, another question is, okay, for only increasing, only decreasing function, there's like one-to-one, let's say for only one-to-one function. If I draw a linear and this linear touch the graph twice, do you think that can't be the tangent? That's not the tangent. Is that true or false? Okay, for one-to-one function, okay, one-to-one function, I draw a linear, okay, any linear. This linear touch the function more than once, then this line is not the tangent. Is that true or false? True. Okay, if it's touched more than once, it's called the second. Okay, it's not the tangent anymore. It's the second. Okay, for this one without restriction, you can't say that's the second. That's not the second. That's the tangent at x equals to A. Okay, only one-to-one function. Like what I mentioned is only one-to-one function. There's no up and down changing, so only touch it once. Yes, but for increasing like only like this or this graph, if I draw a linear and this linear touches more than once, then it will be a second. Okay, it will be a second. Any questions about all this definition? No? No? Okay, if we don't have any questions. Let's have a look at example 1. Okay, let's have a look at example 1. Find the equation of the tangent to the curve, this curve, at the point x equals to a. Okay. Let's say 2 or 3 things when we're trying to find the tangent or normal. What we need, okay, ignore all of this writing here. Or if you want, you can still put in your notes. It's still useful. But you're looking for 2 things, basically. First thing is called the contact point. Okay, what's the contact point? It's the point, the linear touch with fx. That's the contact point, okay, where the tangent contact with the fx. And also the normal, the line perpendicular to the tangent will pass through the same point as well. So it's actually a point of 3 intersections, okay, 3 diagram intersects at that point. That's called the contact points. So I would say that's a comma fa. That's the first thing you need to find. Or say, if you can't find it, you will just use a comma fa to represent that point, okay? So can you find that point? If you can, just find the values. If you can't, just use a comma fa to represent you have a point of contact. If you're not sure, where is it? Okay, second thing is find f dash a. Okay, if you know what's a, you can easily find f dash a, right? With values. But if you don't know what's a value, okay, you don't know the value, I will express f dash a as like an expression in terms of a, okay? Just use a to represent what's the gradient, okay? Use a to represent what's the gradient. Okay, the last thing we will have is use the equation y minus y1 equals to m x minus x1. Okay, so that's the equation we'll use. Well, I know you can use y equals to mx plus c, but it's too hard. Okay, sometimes the number is not nice. It's very hard to express it in that way. So instead of substitute and work out for c, we can directly write the equation and rearrange it to make y to be the subject. And it's easy for calculation. Well, if you really want to use mx plus c, no problem, just use for it. But this is a highly recommended formula that you could use to find the linear or the normal. But for the normal, you know, like the only difference for the normal is we will change that to minus 1 over f dash a, because it's the line perpendicular to the tangent is the negative reciprocal. Okay, it's the negative reciprocal. So it's negative 1 over f dash a. Okay, negative 1 over f dash a. It's the negative reciprocal. But they still pass through the point a comma fa. Okay, that's for the tangent. Then let's do the questions. So first one said find the equation of the tangent to the curve y equals to x cubed plus a half x squared at the point x equals to 1. Okay, at x equals to 1. So at x equals to 1, I want to find the tangent. That's the contact point. Okay, that's the contact point. So when x equals to 1, okay, the first thing is to find that coordinates. Okay, not only x value, I want the coordinates. So y equals to 1 plus a half, that's 3 over 2. So I get the first one, which is 1 comma 3 over 2. Okay, I get the first thing. Okay, that's what we do for number 1. And for number 2, I want to find the derivative at that point. So the dy dx equals to 3x squared plus x. So when x equals to 1, so at the same point, dy dx equals to the, well, I will say m. M equals to dy dx, which is the gradient of the tangent, and that equals to 4. When you sub 1 into the derivative, you have the gradient equals to 4. Okay, very easy, because we have the gradient and we have the point pass through, the linear pass through. So we can use y minus y1 equals to gradient x minus x1. Okay, that's the line for the tangent. Okay, y minus y1 equals to gradient x minus x1. So y equals to 4x minus 4 plus 3 over 2. So minus 4 is 8 over 2. So y equals to 4x minus 5 over 2. Okay. Any questions? If we don't have any question, can you move on to example 2? Okay, example 2 is find the tangent and the normal to the circular function. Okay, for cosine, negative cosine x. Well, if I can roughly, well, I'm not going to sketch it, waste of time. One thing is, if you have the coordinates, okay, that's very important. If you have this point, okay, you have the coordinates, you have coordinates. Remember to sub the x value into the fx to see whether you get the same y value. Sometimes the point they give to you is not on the graph. Okay, in other words, it's not the point of contact. I'll show you an example later, like this page, last question here. I will show you this case. But just want you to remember, you need to check whether the point is on the curve or not on the curve. Okay, we sub pi on 2 into the function, I get 0. Okay, cosine pi on 2 is 0, so negative 0 is still 0. So I have this point on the diagram. So then this point will be the contact point. Otherwise, this point can't be the contact point. Okay, you will see that later. But remember to substitute. It's easy and nice to give you just the x value. You find the y value by yourself. That's a nice and easy thing, because you definitely know that point x equals 1 is the contact point. But sometimes when they give you the coordinates and it's not on the curve, then the question becomes complex. Okay, then the question becomes complex. Anyway, we can do this one first. We have fx equals to minus cosine x, and at the point pi over 2 and comma 0. So this is the contact point. So number 1, we get it already, pi on 2 comma 0. But remember to check is on fx. Second thing is find the derivative. Okay, what's f dash x, everyone? Revision, what's f dash x? Sine x or negative sine x? Sine x, okay? Cosine x will become a negative sine x, and with the negative in front, that become a positive sine x. And I will sub the a value in, which is pi over 2. Okay, what's sine pi over 2? Quickly, what's sine pi over 2? 1. Not 0, okay? 1. Okay, unit circle, pi on 2 is at that position, is 0, 1. The y value is the sine value, so that's 1. Okay, sine pi on 2 is 1. Okay, that's the gradient. That equals to the gradient of the tangent. Okay. What's the gradient for the normal? What's the gradient to the normal? Negative 1. Why so hesitant? Negative 1. Trying to test whether it's right or wrong. This is negative 1. Okay, negative reciprocal. So negative 1 divided by 1 give you negative 1. So we have normal of the gradient of the normal is negative 1. So for the tangent, the equation will be y minus y1 equals to gradient x minus x1. Okay, that gives you y equals to x minus pi on 2. And for the normal, y minus y1 equals to the gradient x minus x1. That gives you minus x plus pi on 2. Nice and easy, okay? These numbers are really good. Okay, not much to talk about for example 1 and 2. Example 2 shows you that this coordinates needs to be checked. That's the thing you need to remember. Okay, I said it about 5 times already. I hope you can remember. You need to check the point whether it's on the diagram or not. Okay, that's example 2. Okay, example 3. Example 3 is find the equation of the tangent. Okay, at any point. Okay, at any point. Before I do that, for this function, my question is it differentiable at any point? Is it differentiable at any point? Well, if your answer is yes, then it's okay. If your answer is no, which point is not differentiable? Which point? 0, 0, y is not differentiable. No, it's continuous. 0, 0 is connected, it's continuous. A sharp point. Okay, that sharp point. Okay, it's a sharp point. If you can think about the shape of this diagram, it's like suddenly changing directions for the gradient. So we don't really have the gradient at that point. Have differentiation at that point. But let's see from the. Let's think about another one. Let's think about this one. X to the power of 1 over 3. Is it differentiable at that point? Actually, I shouldn't explain that. Okay, let's do this one and I'll come back to change it. Why I shouldn't explain that way. Let's think about the diagram. What's the diagram looks like? In which quadrant? Do you remember how we sketched for it? X to the power of a third. You can tell me which quadrant. Well, definitely the first. How about the other one? Third. Well, good. So because it's less than 1, so the shape is this. Okay, my question now is the gradient exist at x equals to 1? Or let's say, is there a tangent exist at x equals to 1? What kind of tangent you can sketch? At x equals to 0. Let's think, like you need to think about this. Let's think about why it's not differentiable. Okay, that will be the tangent, how the tangent looks like. What's the gradient of this line? Undefined. That's why at x equals to 0 is not differentiable. So I will go back to change my answer to the previous one. X to the power of 2 over 3. It's not really because sudden change in directions. If we sketch it better, I can't sketch it symmetrical. It's hard to sketch. Okay, so that's my y, that's my x. If I can sketch the tangent at x equals to 0, it looks like this as well. Actually, it's not a sudden change of directions. Those two, from two sides, the tangent looks the same. Okay, the tangent draw from the left hand side, draw from the right hand side, they have the same tangent. But the thing is, it's undefined tangent, undefined gradient. Like a vertical line got undefined gradient. It's not really because of the change. It looks like sudden change in direction, like a really sharp point there. But the real reason is if we sketch the tangent and we're trying to figure out the gradient of the tangent, it's not defined. Okay, it's undefined. Let's make it more general. For fx equals to x to the power of n, where n less than 1, f dash 0 is undefined. Okay, that's the thing I can tell you. Why? Why is undefined? Because f dash x equals to n times x to the power of n minus 1. Okay, right? N minus 1. Can you tell me n minus 1 is greater than 0 or less than 0? N minus 1 is greater than 0 or less than 0? Less than 0. So less than 0, I can write it in this way. N times x to the power of 1 minus n. Right? What minus means is 1 over, right? And then 1 minus n will be a positive number. Now it's like x to the power of a third, x to the power of 2 over 5, x to the power of 3. Like if it's less than 1, then n minus 1 will be less than 0. Then 1 minus n will be positive. Okay, and I can make a flip, make it 1 over something. Okay, x is the denominator. If you put 0, denominator will become 0. So that's why it's undefined from the equation. Okay, you can't have x equals to 0 in the derivative function because it will be undefined because it's negative. Any other questions? Why is undefined? Why you don't have derivative at that 0 point? Okay, so it's x to the power of n, n less than 1, then the derivative does not exist at x equals to 0. Okay, good. Let's have a look at next, well, not next question, like this question here. So I want to find the equation of the tangent at any point, like basically give a general equation for the tangent, what we should do. So if on the general equation, well, now let's say, do we know the numerical value for the point of contact? Do we know that? In this case, no. Okay, no one give us any numerical values, like say 1 or 2. So what I will do first step, I want to explain, we always use the same procedure to do questions. Okay, so any point, if I don't have the point, what I'll do, I'll use a instead of a number. So I will say a comma a to the power of 2 over 3 is the coordinates. Okay, a comma fa is the coordinates. That's the contact point. Okay, second. What's the derivative looks like? F dash x equals to 2 over 3 times x to the power of minus a third. And f dash x equals to 2 over 3 cube root of x. So what's f dash a equals to? So the gradient, well, I'll say m, is the gradient of the tangent equals to f dash a, and that equals to 2 over 3 times cube root a. now we can write about the equation for the tangent. That's why I said do not use mx plus c and then substitute to find c values. It's very hard to do. Okay, it's very hard to do because think about this, all letters, and it's very hard to calculate. So I will directly use y minus y1, which is this one. Okay, the point passed through that. Y minus y1 equals to the gradient x minus x1. Okay, and I can simplify it a little bit. You know, like I can simplify it a little bit. So how I can simplify it? This a divided by a to the power of a third. So this will become a to the power of 2 over 3. A to the power of 2 over 3. So a divided by a to the power of a third, 1 minus a third, that's 2 over 3. So that becomes a to the power of 2 over 3. And then this is a minus 2 over 3a to the power of 2 over 3 and plus a to the power of 2 over 3. So you can see what we have. Y equals to 2 over 3 cube root of a x plus 1 over 3 a to 3. Okay, that's a whole 2 to the power of 2 over 3 minus 2/3 of that thing. Okay, minus 2/3 of that thing. So you're left with a third of that. Okay, whole minus 2/3, you're left with a third. So that's the general equation. Okay, that's the general equation for the tangent. Okay, general equation for the tangent. Okay, if I tell you now, this tangent passed through the point 0, 1, what do you do? And I tell you this tangent passed through the point 0, 1, and I want you to find this tangent for me. What you will do? You sub what? Sub which value equals to what? So what is 0? X is 0 and y equals to 1. And then what we can achieve? A value. Okay, what's A? What is A? What do you remember what is A? It's that point, right? It's where the diagram actually we find the tangent at the point A. So A is the contact point. After you find A, what you will do to find the tangent? After you know A, like here, sub x equals to 0, y equals to 1, and we find A value. And what you will do? Sub it again into that function, simplify it to know the gradient, know the y-intercept, and then work out the whole equation. Okay, that's what you can do. If we know the diagram this tangent passed through the point 0, 1, we sub x equals to 0, y equals to 1, find the A value. A is the point of contact, and then sub the A back into this again to find y equals to some x plus some constant. Okay, this is the general equation. Okay, this is the general equation for the tangent. If I know the contact point, I can easily solve out anything. Okay, I can easily solve out anything. Okay, let's be a little bit quicker. Let's finish the next example, and I want to talk about focus on example 4. Example 4 is a very important example here. Okay, for example 3. Find the tangent to the coordinate at this point the tangent to the curve is parallel to gx. Okay, the tangent is parallel to gx. So parallel thing will give me the same gradient. So I know the f dash value should equals to 3. Okay, that will give me the gradient. Gradient equals to 3. So 2x minus 6 equals to 3, and x equals to 9 over 2. Okay, and why I know that's 9 over 2 is the point of contact. Okay, because I know the gradient equals to 3, so at which x value the gradient equals to 3 is at x equals to 9 over 2. So I will find f9 over 2 equals to, okay, 9 to 81 over 4 minus, we have 327 and then plus a 5. So that's 81 over 4 minus 22, so it's 88. Okay, 88 over 4 is 22. So f9 over 4 equals 2 minus 7 over 4. Okay, some calculation thing. So I know the contact point is there. And second, I know f dash 9 over 2 equals to 3 because that's what we solved at the beginning. Okay, we know the gradient as well. That's the gradient of the tangent. And that's the gradient of the tangent. So number 3 is to find the tangent. Okay, find the tangent. So y minus y1 is a plus 7 over 4 equals to gradient x minus x1. So y equals to 3x minus 27 over 2 minus 7 over 4. Okay, so this question is not hard, but it's a little bit different different information given to you. It gives you the gradient at the beginning, and you use number 2, like step number 2, to go back to find step number 1, what's the contact point, and then we can work out this equation. Okay, and then we can work out this equation. Alright, nothing special for example 3, very regular questions. Let's have a look at example 4 here. Let's have a look at example 4 here. Read the question by yourself first and have a think why I said this question is different. Okay, why I said this question is not the same as example 1, 2, and 3. What is different? Okay, and also have a sketch of the graph y equals to x cubed plus 2x squared. At the corner, okay, use some space. Maybe use the space here to sketch the diagram and plot that point as well. Okay, and plot that point as well. Have a think what is different. Or if you can't see it, sketch the diagram and also sketch that point. remember to sketch the diagram. Alright, let's have a look. What's the difference? Like, what do you find? What do you notice? The points not on the graph. Okay, if you can see, I have sketched the diagram. I hope everyone can have this on your notes. Okay, because we need to figure out something later. Alright, so if we have this. Okay, and I said that the normal, okay, find the equation of the normal to the curve, okay, to that curve at the point 1 and negative 1. Okay, or I said the normal pass through the point 1 and negative 1. Can you actually roughly find one possibility? Okay, one line is enough. Okay, maybe there's many, I don't know. But trying to find one normal of this curve that pass through the point 1, negative 1. Can you sketch a possible one? Okay, not going to be accurate, but can you find something? Okay, find the normal that will pass through this point for me. Okay, just trying to sketch any. Okay, have a think. What kind of normal can pass through 1 and negative 1? Okay, give me any possible thing. Yeah, a possible one I find is approximately looks like this. Okay, the one I find, well, you might find other ones, that's fine. But what you need to remember is there needs to be a tangent. Okay, there needs to be a tangent. And then we sketch a perpendicular line at the same point, and it's a perpendicular line pass through the point 1, negative 1. You can't sketch at random place. Okay, it must be a tangent exists and then normal exists. Okay, tangent exists and then normal exists. So that will be the possible tangent. Well, maybe not that accurate. We can work out that and then find that later. Alright. Again, even though the question looks very complex, you don't know where to start. What we'll do is, we'll start as the 3-step. Do you know the contact point for this question? Do you know that? No. Okay, we don't know that. So step number 1, we use A to represent the contact point. So it's a cubed plus 2a squared. Well, at any point, I don't know where's the point, so I give a general equation to the possible points. Okay, a comma a cubed plus 2a squared. What's the gradient of the tangent, which is f dash a? Well, I don't have f dash a, I have dy dx. What my dy dx equals to? 3x squared plus 4x. That's the dy dx, right? So at x equals to a, well, still at the same point, at x equals to a, that gives you 3a squared plus 4a. Right, so at any point A, the gradient will be given by 4a squared, 3a squared plus 4a. What's the gradient of the normal, everyone? How you can represent the normal? Haven't heard anything. -1 over 3a squared plus 4a. Thank you. So it's the negative reciprocal. Okay, it's the -1 over the gradient of the tangent. That's the equation. That's the expression for the tangent of normal. Tangent and normal. So gradient of the tangent is 3a squared plus 4a, and tangent of normal is -1 over 3a squared plus 4a. Okay, step number 3 is to write an expression. Write an expression for the normal. Okay, all the normal. What's all the possible ways for the possible expression for normal? Is y minus y1 equals to gradient of normal is -1 3a squared plus 4a x minus x1. So y equals to -1 3a squared plus 4ax minus, well, minus and minus becomes a plus. And you know a and this can become 1 over 3a plus 4. Okay, I can simplify it when I expand it. And also remember to plus the 3xa cubed and 2a squared to that side. I can simplify it, I think. I can use a red color to make the expression. So I can make 3a and 4. So 3a to the power 4 plus 4a cubed plus 3a plus 4, 2a squared plus that is 6a cubed plus 8a squared. What's this? Okay, and then in the front we have this. I make it into the same denominator, and I can express it into a better, simpler way. Have x plus, okay, x to the power 4 is 3a to the power 4 plus x to the power 3 is 10a3 plus square 8a squared and then plus 1. Well, maybe it's not even better, but that's the c value. Okay, no, that's the c value. So gradient is that, and the y-intercept is that. It's just an expression. Okay, that's the hard bit because we can't simplify anything. We can't combine anything. So the expression will look extremely hard, but it's actually the same thing. Okay, what we all do is play with the algebra, like move things around. Okay, we haven't done yet. That's a general equation. Well, the normal 3 step to find all the expression for normals. What else we know is I know the normal pass through the point y -1. Okay, so what we'll do number 4 is sub x equals to 1, y equals to -1 into the equation to solve for a. I'm not going to solve for it. You should solve out 2a values. If you put that into the calculator, you can solve out 2a values. So you will change the y value into -1 and you change the x value into 1. So you only left a as a variable in the equation. So you can use calculator. So I'm not going to ask you to use hand to solve for it. So use calculator to solve for it. You can solve out 2a values. There are 2 such tangent can pass through the same point, y -1. You can use calculator to do that, but it will be really bad. The value is really bad, okay? So you will use approximation values. And after you find A, okay, the last step will be sub A into the normal equation. Okay, because what I want to find is the equation of the normal. So you will sub that into the normal again. Okay, to find what the actual normal is in the way of y equals mx plus c. Okay, in terms of y equals mx plus c. Okay, that's the end of it. There's another way we can find a value as well. I just want to briefly mention that. I can use another way to find the a value. So what I will do is look at the 2 points. Okay, the given point is 1, -1, and this contact point I have used a to represent. That's a cubed plus 2a squared. Okay, on diagram, what I can see. So if I can find the gradient, connect those 2 points. Okay, so what's the gradient connect those 2 points? I can use a cubed plus 2a squared. Okay, y2 minus y1 over x2 minus x1 to find the gradient of this normal, right? That's the gradient of the normal. That will equals to what? Will equals to -1 over 3a squared plus 4a. Okay, that's from the f dash a minus 1 over f dash a. That's the actual gradient of the normal. So the actual gradient of the normal needs to be the same as the gradient by connecting those 2 points. Okay, the contact point and the 1, -1, I find the gradient by that linear. It should be the same as the -1 over f dash a, give you the same gradient. So I can solve out a by using that equation as well. Okay, I can solve out a by that equation and then sub a into the normal equation. Okay, 2 methods you can do. Okay, 2 methods you can do. But doesn't matter which method you use, you still need to go through step number 1 to 3. Okay, step number 1 to 3. So it's just like when you solve for the a, which way you can use to solve for the a value. So you can actually use the gradient form to find the a, or you can sub the thing into a whole equation and then find the a. It will be the same. Okay, it will be the same. Alright, any other questions for today? It's a very important exercise. Okay, one part will focus on this. Okay, one part will focus on tangent, which is really important. So pay attention to everything we have talked about today. All right, that's the end of it.